Okay, today we are factoring when that lead coefficient, which is A, is greater than 1. Okay, prior to today, we factored terms where we didn't have to worry about a number here in front of the squared term. Okay, we started out by creating our two sets of parentheses. Okay. Then we looked at this number on the end, and we had to find factors of that end number. So we're going to look for factors of 10 that have a sum of this number in the middle. Okay, so we want our two numbers to have a sum of -7. Okay, so factors of 10, 1 and 10, 2 and 5, and for 10, that's all of them. Okay, so I want to look for a combination that is going to give me 7. Okay, well, 2 and 5 right here. 2 plus 5 is 7. But I need it to add up to -7. So if I make this -2 and -5, let's see if that works. Okay, -2 times -5 is equal to +10. -2 plus -5 is equal to -7. So this right here is the combination that I want to use. And if you recall, we just put, let's see, we started out with a v and a v here. V times v. V gives me v squared. I'm going to put -2 and -5. Okay, we could FOIL that out and check, and we should end up with the problem that we started with. Okay, so that's what we've done up until now. Okay, starting today, though, we're going to deal with problems that have a lead coefficient, a number right here in front of the squared term. So let's see. Let's do 5x squared minus 18x plus 9. Okay, this is called the Berry method. Contrary to what he told you last year, Mr. Berry did not come up with this method. The first thing we always want to do is to look at all of our numbers here and see if we have a common factor. We've got 5, 18, 9. There is not a single number that goes into all three of those. So we're going to go ahead and put our two sets of parentheses. And I'm going to start out on the Berry method by taking this right here, 5x, and putting it in the front of each parentheses. Now we know it cannot stay that way because 5x times 5x is not 5x squared. So we're going to have to take care of that in a minute. Okay, the next thing that you do is you take this lead coefficient, and we're going to take it and multiply it by the constant at the end. Okay, so we're going to multiply 5 times +9. 5 times +9 is equal to 45. Okay, so we are going to look for factors of 45 that give me a sum of -18. Okay, so factors of 45. 1 times 45. 3. 3 times 15 is 45. 4, 5. 5 times 9. There's my factors of 45. Okay, as I look at these pairs, I want the ones that are somehow going to give me a combination of 18. Well, I see right here that 3 plus 15 is 18. Now remember, I need it to be -18. So let's try -3 and -15. Okay, -3 times -15 gives me the +45 I'm looking for. -3 plus -15 gives me -18. Okay, so there's my pair right there. Okay, I'm going to go ahead and put in -3 and -15. Okay, the last step in the Berry method is I'm going to look and see, is in each group, can I divide those by the same number? Well, in this one I have 5 and 3. They don't have a common factor, So that one's going to stay 5x minus 3. Okay. But as I look at this one right here, 5x and 15, 5 goes into both of these numbers. So I'm going to divide each of these by 5. And when I do that, 5x divided by 5 is x. 15 divided by 5 is 3, so that becomes x minus 3 right here. Okay. If we were to FOIL this, hopefully we get back to what we started with. So doing the first terms first, 5x times x, I get my 5x squared. When I do the outside, 5x times minus 3, that's minus 15x. Then minus 3 times x is minus 3x. Minus 3 times minus 3 becomes plus 9. Combining these two in the middle, I get 5x squared minus 18x plus 9. That's what we started with. So this right here is our final answer. Okay, we're good to go. Now, there's another way to do this called the bottoms-up method. I'm going to go ahead and show you that because I always want to be able to give you options, and one may work better for you than the other. Okay, so in the bottoms-up method, it's a lot like the Berry method. I'm going to do the same problem. So 5x squared minus 18x plus 9. Okay, I'm still going to start with my two sets of parentheses after I check, of course, to see if any of these have a common factor. Okay, this time though, I'm going to start with x and x. Okay, x times x is not going to give me 5x squared. We'll worry about that in a minute. Okay, the thing that is the same on here is you still take this number and multiply it by the number at the end. Okay, so we have our 45 again. So once again, on the bottoms-up method, you're looking for factors of 45 that have a sum of negative 18. Okay, we've already done this so that we know that those two numbers are negative 3 and negative 15. Okay, we already know what they are. So I'm going to put minus 3, okay, and minus 15 right here. Okay, now then, another thing that's different is here on the bottoms-up method, we multiplied by 5 a while ago, and that's really kind of illegal to do. So we're going to fix it by going in and dividing by 5 right here and dividing by 5 right here. Okay, now then, this one right here, 15 divided by 5 is 3, so I'm going to do x minus 3 here. That one simplifies that way. Okay, well, I don't want this fraction here. We don't have fractions in our factored numbers. So the reason that this is called bottoms up is because we're going to take this number on the bottom and move it up right here. And that becomes then 5x minus 3, just like we got a while ago. Okay, I'm going to do a couple of more examples, and I'm going to use the Berry method. If you like that bottoms-up method, I will help you with it in class. Okay, so let's do some more examples. Let's see, new page. Okay, 8x squared minus 10x minus 3. Okay, I've got 8, 10, and 3. There is not a common factor for those. So I'm going to set up my two parentheses. I'm going to go ahead and put 8x and 8x. Okay, remember we take this number and we're going to multiply it by the number here at the end. Well, 8 times negative 3 is negative 24. Okay, so we are looking for factors of negative 24 that have a sum of this number right here, negative 10. Okay, well, factors of 24. 1 and 24. 2 and 12. 3 and 8. 4 and 6. Okay, now then, since this is negative, you know that one has to be positive and one has to be negative. So we're looking for something that gives us 10. Well, 1 and 24 isn't going to work. Okay, but what about 2 and 12? 12 minus 2 is 10, right? Okay, but I want it to be negative 10. So if this one is positive and this one is negative, then I end up with negative 10. Okay, 2 times negative 12 is negative 24. 2 plus negative 12 is negative 10. Okay, so I'm going to put plus 2 minus 12. Okay, order doesn't matter since these both have an 8x right now. Okay, now then, using the Berry method, we're just going to see if these will reduce now, if they have a common factor. In this first set of parentheses, I've got 8 and 2. Well, these both will, they both have a common factor of 2. So I can divide by 2 on that one. I can divide by 2 on that one. When I do that, I end up with 8x divided by 2, which is 4x, plus 2 divided by 2 is 1. Okay, on the next set, common factor, greatest common factor. You want to look for the biggest one. 8 and 12 have a greatest common factor of 4. So I'm going to divide both of those by 4. Okay, 8x divided by 4 is 2x, minus 12 divided by 4 is 3. Okay, that is your final answer. You could double check it by foiling, but just trust me on this one. Okay, I am going to do one more. 6x squared plus 19x minus 7. Okay, no common factor there. So I'm going to start out with 6x in the front of my parentheses. Okay, 6 times negative 7 gives me negative 42. Okay, so I want factors of negative 42 that have a sum of positive 19. Okay, factors of 42. Once again, this is negative, so one's going to be positive, one's going to be negative. So I've got 1 and 42. That's not going to cut it. I've got 2 and 21. That one looks very promising. 3 and 14. I think that's right. 4 doesn't work, 5 doesn't work, and then we've got 6 times 7, and that's the last one. Okay, look right here at 2 and 21. 21 minus 2 is 19, isn't it? Okay, so that would be 21 minus 2. This one needs to be negative. Okay, so there's my pair of numbers right there. So I'm going to put minus 2, and I'm going to put plus 21. Okay, now then, looking inside each set of parentheses, I'm going to look for a common factor. This 6 and 2 has a common factor of 2. Okay, 6x divided by 2 is 3x, minus 2 divided by 2 is 1. Okay, looking in this one right here, both of these numbers, 6 and 21, have a common factor of 3. So divide by 3, divide by 3. Okay, that becomes 2x plus 7. And that is your final answer. Okay, that's the Berry method. I know this went a little bit long. If you're interested in the other method, the bottoms up method, I'm going to do one more bottoms up. If you don't want to see it, you can stop your video here. Otherwise, I'm going to do one more example. Okay, bottoms up. Another bottoms up is what I'm doing. Okay, let me find a good problem here. How about, oh, how about this one? No, I don't like that one. Ooh, how about this one? I don't know what the answer is, so we'll see how it goes. 6x squared plus 7x minus 49. I'm going to have to get my calculator. Oh, I'm not going to do this one with y'all. That's a horrible number. That's one of your problems, though. I'll help you with it. I'll help you with it tomorrow. Okay, how about 4n squared minus 15n minus 25? For those of you that hung on to watch, this is actually your number 11. Okay, there is no common factor, so I'm going to start out, and I'm going to put n at the front of each of these. Okay? Now then, I'm going to take this 4, and I'm going to multiply it times negative 25. That's negative 100. So I want factors of negative 100 that are going to add up to negative 15. Okay? Factors of negative 100, or factors of 100. 1 and 100, 2 and 50. That's not looking good. 3, 4 and 25. Okay. 5 and 20. Look here at 5 and 20. 20 minus 5 gives me 15, right? But I need negative 15, so how about 5 minus 20? So positive 5, negative 20. Plus 5, minus 20. Okay, remember that this multiplying by 4 is really kind of an illegal thing. So I'm going to go back now and see if I can get that to work. I'm going to divide by that 4 again. I'm going to take my numbers and divide by 4. Okay? Now, this one right here, 5 over 4, that doesn't simplify to a whole number, so I'm going to take this 4 on the bottom and move it up here next to the 4, to the n. Okay? So this one becomes 4n plus 5. Okay? That left there and went up there. Now then, this second one, 20 divides nicely by 4. That's equal to 5, right? So this one becomes n minus 5. Okay? For those of you that stuck around, there's another example of the bottoms up method. See you in class, and be prepared with some questions.